Due to the overwhelming response that we've received about the Mastertech 50th anniversary introductions, we decided to continue this tradition by providing you with short segments featuring training tips and up-to-date service information. Stay tuned for this month's introduction, followed by the latest service information about the Chrysler LHS, 300M, Concorde, and Dodge Intrepid.
Someday, computers will replace drafting boards. Someday, technology will make it possible for engineers to simulate a collision or test a traction control system without ever leaving their desks. Someday, designers will use virtual reality to get behind the wheel of a vehicle that doesn't even exist. But at Chrysler, someday is today. A powerful new technology called Catia has revolutionized the way we do business. Catia stands for Computer-Aided Three-Dimensional Interactive Application. Many automakers use Catia to one degree or another, but none have implemented it so completely as Chrysler. At Chrysler Corporation, Catia is a seamless product pipeline fully integrating every aspect of vehicle development. The all-new 1998 Dodge Intrepid and Chrysler Concorde models represent the pinnacle of Catia technology. The first ever paperless cars, they were created from start to finish with Catia. Paperless means that Chrysler designers leave behind paper, pencil, and drawing board, using instead a stylus and electronic sketchpad to create vehicle concepts. Catia makes it simple for designers to experiment, showing how early concepts will look with different paint treatments, predicting how body panels will reflect light, instantly transforming flat drawings into 3D. With Catia, Chrysler was able to develop a pair of new V6 engines in just 24 months, a company record and an industry benchmark. Catia's modeling abilities were instrumental in the process, allowing the powertrain team to simulate internal workings of engines that didn't even exist outside the computer. Catia's ability to simulate component performance allows for stress and load calculations, collision simulations, and can even create a virtual reality vehicle interior. Catia also eliminates the need to fabricate expensive prototypes early in the development process. But when prototypes are needed, Catia can create them faster and more efficiently than ever. Catia reaches into vehicle manufacturing with stamping and welding analyses, computer-generated tooling and dies, and even a virtual reality walkthrough of a plant that hasn't even broken ground yet. Catia technology also extends into the dealership. By linking Catia to the TOPS vehicle ordering system, dealerships have access to current pricing and ordering information on a real-time basis. Catia may also be used to create service publications or even an interactive 3D database that could be accessed by dealership technicians directly from the service bay. But how is Catia technology benefiting Chrysler and its dealers today? To begin with, Catia drastically reduces the length of the product development cycle. What used to take years or months can now be done in weeks, days, even minutes. Catia is a much more efficient process too, helping to lower development costs so that Chrysler can price products more competitively and provide customers with the best possible value. Linking platform team and suppliers together through a common database, Catia eliminates the risk of variations in vehicle components, which results in better quality products. Virtual reality, rapid prototyping, computer-based testing and validation, the first true paperless vehicle design. While others look over the horizon and say, someday, at Chrysler, we log on to Catia and say, today.
Some of you may remember the great Chrysler cars that carried the 300 designation with a letter at the end in the 50s and 60s that culminated in the 300L in 1965. For the 1999 model year, Chrysler is resurrecting the 300 designation and introducing a new model, the 300M. The Chrysler LHS has been redesigned for 1999, and with its many new and improved features, LHS continues to offer an outstanding combination of luxury and performance. Hello and welcome to another Mastertech. This month, we're going to focus on the new Chrysler LHS and introduce a model designation that some of you may recall from many years ago, the Chrysler 300 series, this time with an M at the end of it. In addition, throughout this video, we'll recap some of the revisions to the 1998 Dodge Intrepid and Chrysler Concorde that we first showed you in October of last year. Let's begin by taking a look at some of the features that you can expect to see under the hood. Beginning with the hood, LHS, like the Concorde, now features an aluminum hood, which is 20 pounds lighter than the steel hood used in the past. Steel hoods used on 300M and Intrepid are also lighter than before because of the enhanced inner panel structure. The secondary release mechanism is easily accessible and now yellow in color, making it more visible. Adjustable single pivot rear hinges allow for an accurate hood fit. Gas prop counterbalance supports are used on all of these vehicles. Because of the aluminum hood on the LHS and Concorde, the supports are mounted closer to the front of the vehicle to reduce stress. One of the biggest differences under the hood is the selection of engines. While the Concorde and Intrepid models have 2.7-liter or 3.2-liter engines, LHS and 300M have 3.5-liter single overhead cam V6 engines, which is standard equipment. Chrysler engineers completely redesigned the previous 3.5-liter engine, making it lighter while providing enhanced performance. Like the 2.7 and 3.2-liter engines, the 3.5-liter engine has a cast aluminum block, which is over 40 pounds lighter than the previous cast iron block. Cast-in-place cast iron cylinder liners provide durable wear resistance for long life. As you recall, the 2.7, 3.2, and 3.5-liter engines were covered thoroughly in last month's Mastertech program. Right now, let's review the features of the 3.5-liter engine. Like the 2.7 and 3.2-liter engines, the 3.5-liter engine is non-freewheeling. The pistons have small notches, or eyebrows, for valve clearance in the event a timing belt should jump 1 or 2 teeth. And the piston rings have a new design. The second ring acts as a scraper ring, and it's important to remember that they aren't interchangeable with the old design. The forged steel crankshaft uses smaller bearings for reduced friction. The new exhaust roller rocker arms are Y-shaped and use a new camshaft. The camshaft has 3 lobes per cylinder instead of the 4 lobes used on the old design. With durability in mind, head gaskets are now made of multi-layered steel. The 3.2 and 3.5-liter engines both use a 3-plenum upper intake manifold. The new composite upper intake manifold is reinforced with glass fiber for strength and heat resistance. The manifold tuning valve, or MTV, has been relocated to the front of the engine. The MTV is operated by a PCM-controlled electric motor, which replaces the electronically controlled vacuum actuator used previously. Turning to service, the new coil-on-plug ignition system uses platinum-tipped spark plugs that are less susceptible to tip erosion over time. The spark plugs used in the 3.2 and 3.5-liter engines are different from those used in the 2.7-liter engine. 3.2 and 3.5-liter plugs can be identified by their use of a gasket. When replacing a spark plug, it's important that you use the correct torque. So be sure to refer to the service manual for specifications.